In this video, we're computing a definite integral of a rational function, and the standard trick for this one is that I can take each term in the numerator and divide by that term in the denominator, and then it just becomes a linear combination of power functions. So to prep for this, I express the square root x in the denominator as an x to the 1/2. Now I can split up my two terms, and the first one becomes a 5x squared over x to the 1/2, and I just subtract the exponents. That gives me 5x to the 3/2. In my second term, I end up with an x over x to the 1/2. I subtract exponents, and I get x to the 1/2. Now the fundamental theorem of calculus says all I need to do to get the signed area bounded by a function is guess the antiderivative and evaluate across the limits of integration. So the antiderivative of this first term, I just add 1 to the exponent, getting x to the 5/2, and then I divide by the resulting exponent. That's the power rule for antiderivatives. In the next term, I do the same thing. I add 1 to the exponent, and then divide by the resulting number. It's wise to clean this thing up before we sub in the limits of integration. So dividing by 5/2 in that first term is the same as multiplying by 2/5, and the 5s are going to cancel, and I end up with a 2 out in front. And in the second term, I have a negative 2/3, taking the reciprocal of that denominator, times x to the 3/2. It's all evaluated on 1 to 2. Plug in the upper limit, and subtract the result you get from plugging in the lower limit. When I plug in the lower limit, those powers of x are just going to be 1s, and so I end up with a 2 minus 2/3. And the trick with these fractional exponents in the first part is that 2 to the 5/2 is really going to be 2 to the 4/2 times 2 to the 1/2, because when I add those exponents, I get back to the original 5/2. And 2 to the 3/2 is going to be 2 to the 2/2 times 2 to the 1/2. And the whole reason I did that is because 2 to the 4/2 is 2 to the 2, which is 4. And there's a 2 out in front to multiply. So I end up with an 8, 2 to the 1/2, which I'll write as a root 2. In my second term, 2 to the 2/2, that's 2 to the 1, or just 2. And I'm going to multiply by 2/3 out in front, so negative 4/3, root 2. And in this step, I'll go ahead and combine the 2 minus 2/3 in that second piece. And that's 6/3 minus 2/3, which is 4/3. Finally, we combine the terms that contain square root 2. And 8 root 2 would be 24 root 2 divided by 3. And 24/3 minus 4/3 root 2 would give you 20/3 root 2, or 20 root 2 over 3. And we've got our exact area bounded by the curve. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.